Hello there, it's Alana, and I'm here to help you with 10-2 number 5 from the study plan. So we're going to determine the critical value for a right-tailed test regarding a population proportion. Make that a left-tailed test because I'm going to do the example instead. At the alpha equals 0.05 level of significance. So this is going to be a left-tailed test that I'm going to do for this one. Obviously, it could be left-tailed, right-tailed, whatever they choose to do. Now, there are a lot of ways to do this, so we're going to do it a variety of ways. They're going to show probably the table way. I'll hold off on the table because it's kind of the least important way that we know. But let's look at our lovely Excel program right here. So let's see. I want to type equals norm dot inverse because you're basically doing what we did in chapter 7. You're finding an inverse norm value. But the area in the left tail is what you have to put in for your probabilities. So since this is a left-tailed test, that's cool, it's 0.05. If it was a right-tailed test, I'd have to do 0.95 because you want the complement rule. Now the mean is 0, the standard deviation is 1. That's one way you can do it. There you get negative 1.64, just like they do. Let's give me some other varieties. All right, so this was doing it that way. I could also use norm dot s dot inverse, which automatically knows it's the standard normal distribution, so I don't have to do the 0, 1 thing, and it just put in the probability of 0.05. And again, these are for left-tailed tests, right? If you were doing a right-tailed test, you would do equals norm dot inverse 0.95, 0, 1. Although honestly, and here's the kicker, if you know what one is, you kind of know what the other one is, right? I mean, if the left-tailed one is negative 1.645, then the positive one is positive 1.645, excuse me, for the right-tailed. And you could do it for, oh, hold on. It's not liking me. There we go. I'm having to fight my Excel program here. Okay, so if you're going to do norm.s.inverse and make it 9.5, there you'd go. Right, so this would be right-tailed over here. And then this is left-tailed. All right, so that's finding it with Excel. It's really super simple. If you want to find it with Statcrunch, let me pull up Statcrunch here. All right, so I would go to Stat, Calculators, Normal, and then the mean is 0, standard deviation is 1 because this is a z-score, right? And that's the standard normal curve. So all I would have to do is put in my probability, which I wanted to be 0.05, left-tailed because it's left-tailed, and then click, oops, 0.05. I think I did that wrong. Oh, I'm an idiot. I'm doing it backwards. Sorry. I'm picking a z-score of 0.05 there. I want the area to be 0.05. Sorry. There we go. So I want this little bit to be in a tail. I knew I was in trouble because it kept making this huge tail, and I know that 5% in the tail should be tiny, and there it is. If you want to do right-tailed, you would just flip it the other way, say 0.05 over here, compute, and there it is. So there's a little red bit, 0.05, and there's that. But I actually wanted left-tailed, so 0.05, and then I'm going to take a snapshot. I'm going to call it 10 to 5. Number 1. Pick 1. Export. Cool. And then, of course, if you were doing this on an exam, one of the things I can do is I can give you this picture like this, and then I can ask you, okay, for a left-tailed test, it was this. What would it be for a right-tailed test? And then you'd have to be able to figure it out. That is positive 1.645, stuff like that. Because a lot of times on exams, I mean, not always, but a lot of times we just don't bother with all the rigmarole of finding all that stuff by hand. There's Excel. Paste it. All right, speaking of finding it by hand, I mean, if you had to find it by hand on an exam or something, which generally I don't do, but, you know, if you wanted to, you would use the lovely table, which, of course, you're always given in your exams anyway. So let me pull this up. All right, so it's a little bit kind of confusing, but what this is the areas are in the middle of the table and the z-scores are on the edges, right? So you want to look for where the area is 0.05, which is, let's see, 0.096, 0.01, 0.0505, that's looking good right there. And then 0.0495 is right there. See those two? right? So it's kind of halfway in between the two of them, really, honestly. So, but pick one, you know, whatever. So you go, okay, that's negative 1.6. That's the z. See, negative 1.6, 4, right? See how, like, this gives you the first, like, the first decimal place, the 1, and then the first place to the right of the decimal place, which is the 0.6. So you'd say it's negative 1.6, and then because of the row, or I mean the column you're in, you'd add a 4 onto it. And then because of this column over here, excuse me, negative 1.645, that's the other one. So it's negative 1.65. So here, let me show you. So from the table, you get the low end is negative 1.64, and generally you just go with whichever one's closer. And then but this one is actually smack dab in the middle, because let me write it down. So your area, remember, was, for this one it was negative, oh, not negative, 0.4905, I think, or 04. Hold on, I gotta get it. Negative 0.0505, that's that one. 0.0505, and this one was the 0.0495. If you add up the two of them, if you take the average, so add the two of them up and divide by 2, you're going to get what you were actually looking for. So what you can do is you can take the average of these two. It only works this way if it's actually smack dab in the middle, which this one is. Otherwise, you go with whichever one is closer. In this case, neither one of them is closer. They're exactly the same distance away from that middle. So that's the right answer. And if you look at these ones, that's actually what this answer rounds to. So if you round that answer to 3 decimal places, you're going to get negative 1.645. See? So the table only lets you be so accurate. In general, in the table, you go for whichever one's closest to the area you actually wanted. This one didn't actually have that. This one, they were identical distance away, so you would actually add the two of them up and divide by 2, which is pretty rare, honestly. All right, so what if it was right-tailed? Well, the table's giving you left-tailed. You just take the positive one and boom, you got right-tailed. That's all there is to it. Let me see, what's the other? Yeah, that's the, and this is the other side of it. So if you wanted to do this side, like, let's say you were looking for a right-tailed test, so it would be the area to the left of that is 0.95, right? Because if you, let me bring back up Statcrunch, because Statcrunch does a better job of showing the picture. So if I go to the calculators, I go normal, and I say, okay, it's 0.1, I put 0.95, there we go. See, the 0.5 is the white bit in the table, and then the red stuff is 0.95, right? So the table always works left-tailed. The table doesn't have this little pull-down menu where you can switch back and forth. So with the table, you're stuck with always looking to the left side. So you would say, you know, okay, well, if I want a right-tailed test, I would go 0.95, 0.95, 0.95. Look right there. That one's 9495. That one's 9505. They're equal distance. Rats. That means I'm going to have to average these two numbers out, which is 1.64 and 1.65, right? So the 0.9495, here, let me write that down. So this was left-tailed that I did, which was the example. If you were going to do a right-tailed, just for the fun of it, all right, so you had a low number, which was 1.64. You had a high number, which was 1.65. This one gave you 0.9505, I think. Let me go back to that table. Let's see, 0.9505. Oh, that was 1.5. All right, and then 9.9495 is the other one. 0.9495. And again, this is kind of weird. It's pretty rare that you actually would take the average of the two of them, because there's very few times in the table where they actually are equal distant, as this table value was. They're not really equal distant. They're only equal distant in terms of 4 decimal places. If you go on much further than that, you can see this isn't exactly 1.645. It's 1.64485, meaning they're actually not exactly the same, but for the sake of the table they are, because it only goes to 4 decimal places. So again, the table's much, much, much harder. If you just have Excel, you can just do norm, inverse, you're done, or norm est inverse, tomato, tomato. If you have Statcrunch, you can use that and find that really quickly. The table's kind of a pain. And again, in general, I don't make students find z-scores by hand from the table, at least not from the normal table. There is another table you can use that's actually much faster that I would generally use for simple ones like this. Let me bring that up real quick. And it's in the documents, just FYI. Or it's in the tools for success even, because it's a standard thing from your textbook. Yeah, the formula table card. So you can click on it there and you can get to it. See, and look, a whole bunch of formulas that might not be a bad idea to have on your exam. Just saying. There's the normal distribution one, which I'm saying is kind of annoying. The t-distribution one is really nice because if you go to the area, look, the area in your right tail is 0.05. If you drop to the very, very bottom, you can see the z-score. Look at that. Hold on, you probably can't see it. It's so small. 1.645. See it? Right there. This only does a few of them though. It only does like 0.05, 0.025, that's it. Like what if it was 0.03? You're out of luck, right? Then you'd have to use norm inverse with Excel or with Statcrunch or something. But for a quick reference to some of the basic ones, the bottom row of the t-table is really nice, right? And this was one of the basic ones with the 0.05. Okay, so to recap real quick, you can use a table. If you are going to use a table, pray that it's one of these ones in the t-distribution, which are generally the ones I put on exams anyway, because, you know, if I want you to do a quick reference one, I'd probably pick one of these ones from the bottom row of the t-table if it's a z-score. If it's a t-score, which we learn about in the next section, then that's all these ones in here. That's why you have to have this table on an exam. Okay. If you're stuck, then yeah, you can use the standard normal table. It's not my favorite thing, but you know, whatever. If you're not stuck, if you're near a computer or a calculator, then you can use Statcrunch. Right, with the normal calculator, just putting in, since I was doing a left-tailed test, I would do 0.05 like that, compute it, you're done. Or I can use Excel, right, either norm inverse or norm.s inverse. All of the computer options are obviously a lot nicer than using the by hand table thing, right, especially the normal table, which is not my favorite table on the planet. But it's what people had to use before calculators were invented. So calculators and computers, I should say. All right, I hope that helps. See you later.